Okay, YouTube, in this video we're going to introduce the concept of the polar coordinate plane. And really what this is just another way of representing a point in our XY coordinate plane. And so what can be said is that we're certainly used to representing points in, say, some XY sense here. We could say that this is some point right here. But what I would like to think of is, would there be another way to determine the location of this point than for me to just simply say that you walk X units in this direction and Y units in this direction. And of course, one thing we could do, I suppose, is say that, to get to this point, you would have to walk a certain distance from the origin to get there. And what we're going to do is we're going to refer to this distance here as r, as we often do when we represent things with x and y in the xy coordinate plane here in trigonometry. But we'd say that this distance r is going to represent the distance to this point. Now, would that be enough information for me to tell you how to get to this point right here? Just say that it's this far away from the origin. You could see that if I told you a distance away from the origin, we would be describing maybe a set of points all on the exterior of a circle, but that still on its own wouldn't be enough to tell you where this point would lie. So the other variable that we're going to use to describe where this point lies is going to be this angle right here, theta. And we're going to say angle when it's in standard position, of course, when it leaves from 0-degree rotation. So the polar coordinate system, we're going to use what are called polar coordinates to describe this point right here. And we're going to refer to these points, instead of being an x and y, as being some r comma theta, where r is the distance away from the origin and theta is the direction that we're heading in here. And so what we're going to look at here basically is, in terms of vocabulary, some anatomy of polar coordinate points. And so we say that the foundation of polar coordinate system is a horizontal ray that extends to the right. And so this horizontal ray here, you can see that what we refer to as the pole is kind of this imaginary, say, axis about which our point, maybe rotates in a clockwise or counterclockwise direction here. So we'd say that the pole, normally in the xy coordinate plane, usually lies at the origin here, and we're rotating some angle either clockwise or counterclockwise. But we'd say that the polar axis is this axis that extends from the pole to the right. And so when we represent this in the xy coordinate plane, we really refer to the polar axis as being at 0 degrees or 0 radians, okay? And so that polar axis, what we're doing is we're rotating from this polar axis, either clockwise or counterclockwise, and then walking from the origin in that direction r units. And so we say that the endpoint of the ray is called this pole right here. Our positive x-axis here, what we refer to as a positive x-axis, usually is going to contain our polar axis now, and all we're doing is rotating some angle, and walking some distance. So we say that r is our directed distance. So we're going to make a little note here. R is the distance from the point. We're going to be clear on this. R theta is our point to the origin. Okay. And so we say this distance here is our r. We also say that theta is an angle from the polar axis to the line segment from the pole P. And so you can see from the polar axis, we say theta is the angle in order to get to this terminal ray here. And so we could say that we could measure this in degrees and in radians, this angle. And we say also, noting that positive angles are measured counterclockwise from the polar axis and negative angles are measured clockwise. And so really kind of similar here, we could say that this right here, this is a positive theta. If we had set a negative theta, then we would have been rotating down here, maybe to this point right here, we'd say some r distance, but we would say that this would just be a negative theta right there. And so that being said, what I want to do kind of in this video is just kind of look at how, if we get a point in polar form, some r theta form, how we could just go and graph these points, okay? So the first thing I want to do is consider this point here, 3 comma pi force. Now the first thing I want to mention here is that when you look at this point, this is in r theta form. And so the two bits of information we're getting here is that r is 3 and that our angle is a pi force angle here. And just to show you that we could do this in degrees also, we could have written this point up here as 3 comma 45 degrees. And so what this is really telling us is, and you can see this here, that our polar axis located on the positive, what you would consider to be the x-axis if we had imposed a grid on this. But basically lying to the right here, we're going to rotate first of all pi force radians. And then what we do is, you can see this number line here, and they've numbered this -5 to 5, but we're going to walk 3 units in a positive direction here. And so if we were to walk 3 units in a pi force direction, you could see how this point could be classified as the point that is 3 units away in this direction right here from the pole. And so when we read this here and when we graph these things, the first thing we always do, one, graphing polar coordinates. The first thing we want to do is acquire the angle. So I think it's ACQIRE. Acquire the angle direction. Okay, and so what we want to do is just figure out what direction we're heading in. Okay, and then move away from the pole. Are units in the appropriate direction. I apologize for the handwriting here. In the appropriate direction. So let's talk about appropriate direction here, and then we'll sketch a few of our own points. But when we talk about appropriate direction, you notice here it says that the sign of r and a point's location in the polar coordinate plane. And so if we had said up here r is 3, then what that would have meant is that we were walking in a pi-4 directions 3 units. But what if we had had a point that said -3 comma pi-4? What would have been the difference? And what you could see is on this number line, we would have just walked 3 units in the other direction. So the crazy thing here is this. We're always going to face the direction that we're heading in, but we're either going to walk in that direction if r is positive or the opposite direction if r is negative. And so we say that the point P, if it is defined as some r and some theta, is located the absolute value of r units away from the pole. That is to say that this distance from the point back to the origin is always positive. Well, I don't want to say r is always positive, but we'd say the distance from this point back to the origin is always positive. But we say that if r is positive, the point lies on the terminal side of theta. That is to say that if our angle is pi-4, then it terminates here in the first quadrant, then our point lies on that terminal side right there. But they mention here if r is negative, then the point lies along the ray opposite the terminal side of theta. So if up here our terminal ray is facing in a pi-4 direction, then our opposite ray would be facing the other way. And so basically, if r is negative, then we're going to go in the direction opposite of our angle theta. So what I want to do here in this video is graph these 3 points right here in a polar coordinate plane, and then have you try 3 on your own here. And so starting with this first point, we can see that our r value is 2 and that our angle is 135 degrees. So using the method that I used first on the other page there, we say first get the angle, okay, and then walk the distance. So walk the distance r. And then angle theta is what we're going to do first. So 135 degrees, you can see that in this particular graph here, we have, looks like pi-6 up here. So 1 pi-6, 2 pi-6, 3 pi-6, 4, 5, 6 pi-6. We also have pi-4s, so we have 45, 90, 135, and 180. We also have pi-thirds at our 60, our 120, and our 180. So with this here, we can kind of use this to navigate. We can see that 3 pi-4s, 135 degrees, if we're doing this in degrees, would lie along this right here. And so what I'm going to do is I'm going to put in this imaginary dotted line there and say that our angle right here is 135 degrees. So the first part of this is no longer a mystery. We lie along this line. And then the second part is that we lie 2 units away. Now because we lie 2 units in a positive sense, we're going to walk 2 units in the 135 degree direction here. So that would mean going in that 135 degree direction right here, we would label this point as being the point 2, 135 degrees. So now looking at some of these other points here, and you know what, honestly, what I'd like to do is kind of get all this other stuff out of the way. I don't want it to be in the way because we're going to put all 3 points on this graph here. So we'd say rotating 135 degrees and walking 2 units out, we'd say here's our point 2, 135 degrees. Now, when we look at -3, 3 pi halves, the first thing I notice here is 3 pi halves is a quadrantal angle. That is to say that we have pi halves, okay, pi, and then 3 pi halves. So we're going to be heading in a 3 pi halves direction, or at least our angle is going to be facing that way right here. And so you can imagine this imaginary line running through this right here. But the question is, are we going to walk 3 units in the 3 pi halves direction or 3 units backwards? And because it is a negative r value in this case, because it's negative, we're going to walk 3 units backwards here. And so this would be the point that if we were to walk backwards 3 units from a 3 pi halves direction, we would be located at this point right here. And so for this last point, -1, we could also see that this is a situation where we're going to have to walk in the opposite direction of negative pi-4. But we also see that we have a negative angle here, negative pi-4. So negative pi-4 would just mean that we're going to rotate clockwise pi-4 radians here. So here's our pi-4 radian. And because we're going to walk backwards 1 unit, that would extend backwards this way. We'd say that this would be this point right here. So we say backwards 1 unit from a negative pi force angled direction. And so these are these 3 points here. So what I want you to do is pause the video and graph these 3 points on your own. Okay. When you're ready to check out the answers, go ahead and hit play again. So the answers here after you've hit play, when we look at this, it looks like we have an R value of 3 here and that we're heading in a 315-degree direction. So the thing we should do is we should wrap around to 315 degrees, which in standard position from the polar axis would lie over here. And so we'd say, since this is the direction we're heading in here, we're going to head 3 units in that direction, since our 3 is positive. And what we get here is this point here, 3 units away in a 315-degree direction. For our next angle here, negative 2 comma pi, well, we know that pi lies in this direction here, but because our terminal ray goes this direction, but our R value is negative here, we're going to walk backwards 2 units. So we would say from a pi direction, walking backwards 2 units, it would put us here, and we'd say this is the point negative 2 if you're facing in a pi direction. And so our last point here, negative 1 comma negative pi halves. Negative pi halves would just mean that we are rotating this direction here counterclockwise or clockwise here. So we say here's our negative pi halves angle, but are we walking in that direction? And because this is a negative 1, it means we would walk backwards 1 from that direction. So we'd say here's this point that is backwards 1 step from a negative pi halves angle direction. Cheers.